Hello students and welcome to Math Weekly 21 where our focus skill will be on the Pythagorean theorem on the coordinate plane. We have already looked at the Pythagorean theorem for the last 2 weeks, but this is going to be specific to the coordinate plane and when we're not given a distinct triangle to start with. So let's begin with just a review of what the Pythagorean theorem is. The Pythagorean theorem is a consistent relationship between the three side lengths of a right triangle. For any right triangle, the sum of the squares of the two legs is equal to the square of the hypotenuse. And in other words, that means a squared plus b squared is c squared. The legs squared added together always equals the hypotenuse squared. The Pythagorean theorem can be used to determine if a triangle is a right triangle, and that was the focus 2 weeks ago in past Math Weeklies. And this week we're looking at how can we determine the side length of a right triangle on the coordinate plane, and that's our focus this week. So here's how to determine an unknown in a right triangle on a coordinate plane. First, if necessary, plot the points you want to know the distance between. Second, if necessary, connect the points to form a right triangle. Afterwards, label the legs A and B, label the hypotenuse, which is the longest side, C. Substitute your values for A, B, and or C depending on what you're given. Leave the variable for your missing measurement. Solve the equation by using inverse operations. The steps you will take will vary depending on whether it's the smallest, medium, or longest side of the triangle. But likely, 9 chances out of 10, you're looking for the longest side on the coordinate plane. So let's learn to find the distance between 2 points. It says calculate the distance between -3, 2 and 5, -4. Now at first glance this does not seem like a Pythagorean theorem question, but anytime you want to know the distance of something, the Pythagorean theorem at this point in your mathematical career is your only resource. So let's plot these points. -3, 2, so to the left 3 and up 2, so this is your first point. I'm going to call it A. And this is your second point, 5, -4, so going over 5, down 4, this is length B. Now if you connect those, okay, that gives you a very straight line between them. But you can see you can't count this because you're not even sure how long this diagonal is. You know that up and down is 1 unit, but diagonally is not 1 unit. That's longer. So we can't actually count to figure out the length of a diagonal on a coordinate plane. However, we could make this into a right triangle. So we go down until we're in line with B. And then we go to the right until we're in line with B. Okay, so there is our triangle ABC. I just went straight down and straight over. Now, did this say anything about a triangle? No, but I can form a triangle. Here's my right angle. So this length over here, the one that I'm looking for, is what I don't know, which is going to be the longest side. I'm going to call this A as my short side, B as my medium side. Now, how do I figure out how big A is? Well, I just count the blocks. 1, 2, 3, 4, 5, 6. So this is 6 units long. 1, 2, 3, 4, 5, 6, 7, 8. B is 8 units long. And remember, C, I don't know. And now I use my Pythagorean theorem. A squared plus B squared equals C squared. So I have A, which is 6, so 6 squared. B, which is 8 squared, equals C squared. 6 squared is 36, 8 squared is 64, and I get C squared. 36 plus 64 makes 100, so 100 equals C squared. The opposite of a square is a square root, so I get C equals the square root of 100, or C equals 10, because 10 times 10 is 100. So this length between these 2 points is 10 units. So 10 units is the distance between the points -3, 2 and 5, -4. Okay, let's do one more example, and we're going to look at finding distance on the coordinate plane. Again, you will see nothing about the Pythagorean theorem in the wording of this question. It just says, calculate the perimeter of isosceles triangle ABC. So we know that AB is equal to BC. It's isosceles. That means two sides are the same. Now, we can start to figure out the perimeter easily from along segment AC because it's just a matter of counting. 1, 2, 3, 4, 5. So this is 5 units. But these two sides are more difficult. But if you look at this segment right here, just at this segment right here, I could make it into a right triangle just like that. See that right triangle? I'm going to color it in so you can see which one I'm talking about. That triangle right there. Now, I want to know this side length right here. I'm going to put a C on there. This long side right here. So I can use the Pythagorean theorem by figuring out how big these legs are. So this one's 2.5 blocks, so I'm going to put 2.5. And this one's 1, 2, 3, 4, 5, 6. So A is 2.5, B is 6, and then I'll know what C is. And if I know what C is, then this will be the same length since it's isosceles triangle. So I'm going to use my Pythagorean theorem. A squared plus B squared is C squared. A is 2.5, B is 6, and that's equal to C squared. So I got 2.5 squared, so I'm going to do 2.5 times 2.5, which is 6.25, plus 6 squared, which is 36, equals C squared. So I'm going to add these two together. So I'm going to add 36, and I get 42.525 equals C squared. The opposite of a square is a square root, and square cross out. So I get C equals the square root of 42.25. You can use your square root button to do that, and you get C equals 6.5. So now we know that we use this triangle to figure out this side length, which is 6.5. And if this one's 6.5, then this one's 6.5. So the perimeter is 6.5 plus 6.5 plus 5 more. So there's one around the outside, 6.5, 6.55. 6.5 and 6.5 makes 13, plus 5 more makes 18 units. So the perimeter is 18 units for triangle ABC. So let's summarize what we've learned about using the Pythagorean theorem on the coordinate plane. Remember, the Pythagorean theorem states a consistent relationship between the three sides of a right triangle. In the formula a squared plus b squared equals c squared, a and b are the lengths of the legs of the triangle, and c must always be the length of the hypotenuse. The Pythagorean theorem can be used to determine if a triangle is a right triangle, but can also be used to calculate a missing side length for a right triangle and can be on the coordinate plane.